very good. I hope you should be able to see my screen.
Yes, let me make sure. Yeah, we can see it.
Okay, that's perfect.
Okay, I'm going to go quiet and shut off my video so that there's no disturbance, and I will appear as required.
Okay, perfect. So thank you very much, Murphy, for the introduction. My name is Andrea Fabrizi, and currently my role is product manager at HP-Packard Enterprise for big data analytics solution. My responsibility is to develop the storage component of the AI and analytic solution for both HP and our partner. And today I'm going to share with you some of the element, the characteristics of we think about when we're talking about storage in general data platform for supporting AI and analytics. So quickly, AI and analytics is the top priority for any company. This is happening in the last few years, and that's will remaining the top priority for probably more than the next decade. So definitely all the problems related with AI analytics will be top priority for any enterprise, especially for the IT. And the key aspect of AI is that there is an enormous number of AI use case. So this means that the solution that AI people, but when I'm talking in this case, I'm not talking only to the people that are responsible for the, let's say, infrastructure to supporting the AI, but also data scientists and analysts have to be aware about the infrastructure they have below, because unfortunately, there is no a single solution that can fit any of the characteristics of the AI analytics use cases. There are too many, too different. So definitely we are observing that to go, if you want the maximum level of performance, you have to go towards specific specialized solution. Otherwise, obviously, you have to lose something in terms of performance. So definitely, this enormous number of use cases, this enormous potential behind AI, produce several issues, several challenges on the, let's say, infrastructure side. So AI is not only a model problem, so it's not only analytic model using the right models to representing and simulate a problem, but is also and especially an infrastructure problem. Today, the main problem to support AI data store are representing and explaining in this slide. So, first point, model training requires a fast data store. A GPU can absorb or need to be fed, if you prefer, with something ranging between 1 gigabyte to 10 gigabytes a second. And you can have a single machine like an GDX from NVIDIA or equivalent machine from HP that has 8 GPUs on board, and you can have a model that runs across a cluster of several of these machines. So you can see the throughput needed to manage this and to feed this machine is amazing. The reason it's easy, the GPUs are very fit for running AI model, so they can perform, GPUs can perform the role of 100 GPUs. So when we're talking about GPUs, we are thinking about the equivalent in terms of 100 GPUs. So first problem is the amazing throughput that you need to run this model, because otherwise the money you spend in creating a GPU's infrastructure will be lost, and moreover, the training will take much more time than expected. The other big problem in the company is there are a plethora of data silos. So data, even if a company has spent a lot of money in creating data lakes, they're creating a lot of data lakes. So again, data silos is another problem, because these data are continuously copied from one part to another one. Scalability. So we are talking about amazing huge data set. So in this space, we move from terabyte to exabyte to zettabyte. So we don't have any prefix anymore to describe the volume of the data. And lastly, I mean, efficiency in the data pipelines, and also not lastly, is the problem related to the managing metadata in a real space. All this data need to be described, otherwise they would be completely useless. So in this section, I'm going to more in deep describing the requirement of AI in terms of storage and infrastructure. I think this is very important for data scientists to understand what they have under the hood, because that's critical for them to deploy correctly their model and also set up the expectation. So the first message to me is that the AI in big data has dramatically changed the way data are stored and managed. So data has been storage and managed, let's say, in the same way for more than 30, 40 years from really. So in the traditional environment, we have typical application like CRM, ERP that was producing data. This data was stored in the database of this application, and this database was using what is called primary data storage. That was a traditional storage that you can find in most part of the data center. So sun attached system, big storage component, all this stuff was provided. And the aspect that is when the data starting to be old, so for example, CRM generally throw away data every 6 months, older than 6 months. These data are moved to lower cost system called secondary data storage. But you can imagine secondary data storage like a way to manage data on a lower cost system. In the past it was tape, now we have object or different kind. But the concept is that the data move from the upper layer to the lower layer, so north to south, and the tiering is based on the data age. AI and big data has completely changing this model. Data are ingested from any system, so it's not only anymore traditional enterprise legacy system, but we are talking about any source of data that the company has or can buy, because I mean, we are talking also company that ingest data from a third party to enrich their data set. All this data goes in data lake, object data store. Some company, a lot of companies use cloud, but conceptually, company are creating a huge data lake. We can starting to talk about data seas, where they keep this data, and the different application, the AI application that running in different departments, from fraud, financial, recommendation, wherever, they get this data to do the analysis. And generally speaking, to accelerate their model, they use specialized data store file. So for example, in the AI space, you have that the people extract the data to the data lake, they copy on fast data store and they run the model from the fast data store. Graph and social, generally the idea is to move the data in a memory system or in a local system, because otherwise graph and social analysis will take years. So the model is completely different, that you can see. So it's not north, south, is more east to west, as the people say. So the people goes to the data lake, and from the data lake, the data are extracted and reinjected. More important, the data doesn't age. So the data lake contains data for 4 years. And this is not data that I leave here just because I have to do for legal purpose, but because I use marketing do analysis on the data up to 3-4 years back. And this is continuous. So you got the preference of the people. You want to analyze, yes, the recent preference, but you want to know also the preference history of the consumer. So data doesn't age. So the data tiering, so the storage part of the data is basing on the data access. So depending on which application use the data, I'm trying to create a data store. In terms of data store, it's not only storage, it's not only hardware, it's the combination of hardware and software-defined storage. So to be optimized for the analysis, because this system, the system above your AI model system, your graph social analysis system, or your batch and streaming analytics are extremely sensitive on the data speed. And you need to have a specific solution to optimize the investment you have in the analysis part. Let's see why that, because I mean, let's go in a little bit more in details on what's happened to this data from day creation. So data are created by sensor, application, wherever. They are ingested. The ingestion can be in real time, can be batch, in the data lake mostly. And after that, they started to be extracted for data preparation, from the data preparation to the model training to the inferencing and data ingestion. I mean, you have these cycles, and this is a cycles every time. Let me do an example. Automobile driving. This is a very extreme process, but I mean, in the automobile analysis, car manufacturing collect a lot of data. Some people talk about 1 petabyte of data every day for a single car. But before using this data in your model, so going back here, you have to prepare this data. So you got one day of driving data, you have to extract the right sequence to analyze, you have to categorize, you have to create the data set. And this is data preparation. This is not something that you do on a GPU machine. This is something that you do on traditional system and on traditional storage. And after that, this is data that are available for model training and later to the testing the model to the inferencing. So in each of these phases, when you're talking, there is a different need. And obviously, we are talking, okay, on the edge side, we're talking mostly about capacity. So systems that need to have capacity. When we do the ingestion, obviously, you have a mix of capacity and performance, and the ingestion is throughput oriented. You do only write, it's all sequential. On the data store aspect, where you store the data, obviously capacity is leading. Again, throughput oriented, I/O for very large file, sequential read and write, because you extract, you write a lot of data. When you do data preparation, that's a mix, because you need to manage a small and large file. You have an hybrid 50-50% between read and write. When you move to the model training, you have a different scenario, only performance, high bandwidth, read, 100% read, very small latency, sequential reading, that's it, that's performance pushing. And when you move to the inferencing, is even worse, because the inferencing is extremely sensitive to the storage. So in the model training, you are a little bit less storage throughput intensive, because the CPU have to do a lot of calculation. But when you do in the inferencing, so you test your model, the GPUs adjust to run the model. So it just throughput. So that's the reason why you see that sometimes some systems are faster in the training space than in the inferencing, because if the storage is not really well tuned or well suited for the inferencing, the GPUs spend a lot of idle cycle to do nothing, because they don't have data to inferencing. So this is a long story to say and explaining in more in details the life cycle of the data in this new world and different characteristic of the storage in a different space. That's translated in a very simple message. The data architecture that have to support AI analytics must be balanced performance and capacity. Again, there is no a single architecture that can do that, like storage solution can do that, but you have to balance these two elements. In this slide, they're presenting three main scenarios. So on the top, you have the GPU cluster, so the system that consumes the data. And on the bottom part, we have different architecture. And that means that are different way to approach AI. Starting from left, that's the very simple mechanism that a lot of companies use. So the data are in the high capacity system, they are in the data lake. The data scientists go to the data lake, they do the analysis and the preparation of the data, and after that, they load the data in the internal disk of the GPU machine. And when they finish the loading of this data, they run the system. And I mean, they run the training. And obviously, if the data set is too small, it's too big to fit in the disk, they can split the epochs in several batch and working. And again, this is a very simple way, but obviously it's extremely time consuming because the data scientists spend a lot of time into do copying and copy. And moreover, it's very ineffective when you want to use a lot more than a single machine to run your training. But I mean, in environments that are not running a huge training model and the data set are not huge, this is a still valid approach. And you spend all your money in the GPU's environment rather than do. When you move, let's say, in a more complex environment, you can think into have what is called a single tier architecture. So a single storage environment that is a balanced combination between performance and capacity. And when I mean capacity, I mean cost-effective capacity. So a lot of solutions are now able to scale up to dozen, hundreds of petabytes. But one question is to be able to technically scale. Another question is to be able to be cost-effective. So this scalability would not cost me a fortune. And again, in this case, the data stay in the architecture, the data store architecture, and when this model is trained or it's inference, the data are streamed from the solution to the cluster, the GPU cluster system. Obviously, in this case, we are talking about a high throughput protocol. Generally, some companies use pure NFS that is not really amazing efficient, especially if you have few system running, few client, or you can have RDMA, NFS over RDMA, so it's supported that this new approach for NVIDIA. But generally, let's say that this kind of solution try to balance performance. So they sacrifice a little bit performance and the for capacity aspect. The good things is that you have generally a single solution. Generally, these are network area storage solution that do that, and on NFS system. And generally, they are easy also to manage. The problem is that when you have a very large environment, AI environment with a lot of GPUs, system, big training system, etc., you need to have more flexibility than this solution generally offer, because you need more performance from one side and more capacity to the other one. And again, in most part of this case, you need that the data lake or the AI capacity will be split in premise or in the cloud or in hybrid. So you're starting to have a very complex architecture, because the data can be not only, let's say, in premises or all in cloud, but it's starting to be locally. And I mean, when you're talking about performance, you have to be run the data in premises mostly. And in this case, you have the separation between the high performance system from the capacity. And before the training, generally you load all the data in the high performance, and high performance is able to provide, to feed correctly the GPU machine. In this case, we are talking about the parallel file system, like could be Lustre, could be Weka, we have, and several other that are optimized to do streaming on a parallel way, so they can provide the throughput in the order of hundreds of gigabytes a second to the machine. That's the volume that this machine can consume, the GPUs can consume. So we are talking about hundreds of gigabytes, not bit. And obviously the network have to be consequentially structured. We are talking about the using network fabric element, because that's the only one that can support such kind of volume of the network. So the conclusion of this analysis is that throughput is an important part of AI structure, but it's not the only aspect, the only requirement. So you have to combine performance and capacity. You have to have operational maintenance capability. So we are not talking about single system. We are not talking about department solutions. So we need to create solutions that are easy to manage by company. They don't need the specialized skill set, that they don't need to impact people. Data scientists can use them easily. And if they need to copy the data from one system to another one, they don't need to talk with IT to manage a process to do that. So the operational maintenance is a key aspect as the performance. And lastly, existing infrastructure matters. So what is already in your company has been a huge investment for your company. So when you select this kind of solution, you have to consider the compatibility and the interoperability with existing storage solution. And very important that the solution you selected should be working in an hybrid environment. So you are expecting that part of your data will be locally in your premises, in your data center, part will be in the cloud. Some part of the data is expecting to be in the edge. Edge will be probably the next cloud in the next decade. So the storage system in the edge is starting to be bigger and bigger. So you're starting to have data different location and entities in your system have to be able to manage transparently this data. So you don't need to know where all this data are to run your system or to get your system back, your data back. You have to have a transparent data management that allow you to get the data wherever they are in a transparent way. In this new section, I'm going to present some example of high data throughput data store system, so performance-oriented data platform. And after the next session, I'm going to provide an example of capacity-oriented data platform. So in this case, just to go back and present, you see in the top right of the slide, you see that we are talking about this layer. So we're talking about high performance oriented data platform. So what are the requirements for a fast data store? Scalability. So even if we are talking about performance, scalability is a must. So data set for a training system are huge. More data you have, more precision generally you have. So data sets tend to be very massive. I don't want to get again the example of the autonomous driving, but also if you want to run any kind of image recognition system or even a churn management or fraud management system, the data set you need is huge. So the fast data store should be able to host up to petabyte of data set, also because you don't run a model only, you generally run several models in parallel for different departments. So the fast data storage should be a system that is scalable. Throughput, obviously, we talk a lot about throughput. The GPU is amazing. It's voracious, we can say, in terms of data. So the throughput is be in the order of 100 gigabyte, above 100 gigabyte at all to manage. Latency, again, GPU system, but generally all the analytics system are extremely sensitive to latency. So if between one file and another one, there is a long time, the GPU doesn't work. So I mean, they're starting to go to idle. So latency, the capability to manage slow latency is critical, as the capability to manage small file. A lot of, especially in the image recognition space, but not only, file tend to be small, especially when you start to run the model for the first time. You don't want to have large image, because otherwise the deep learning model will take a long time. So, and generally, so you work generally with small image by, let's say, 200 by 200, or in this order of magnitude image, for starting to see if the model works correctly or not. And after that, you move to bigger image for the optimization and the final verification. So small file is very important. It is an extremely important aspect, because it was probably small file management is one of the biggest critics that the community has with Hadoop, because Hadoop is not good at all to manage small file. Parallel access, it's definitely the right approach for supporting large throughput. Traditional single access is too slow, so you have to work and be able to stream parallel access to reach the throughput that has been requested. As I mentioned, HP has two solutions that address the fast data storage. One is the combination with Weka file system hosted on HP ProLiant. So it's a combination. Again, when we are talking about this solution, we are talking not only about the hardware, but we're talking about a combination of hardware storage optimized. And this kind of solution, for example, in the case of Weka, they have a lot of optimization in terms of RDMA approach, optimization in the management, and also in the case of Weka use as two options, using a traditional NFS and RDMA, or they have a specific proprietary client that make obviously provide additional performance. So as you say, this is a very specific solution for hyper fast performance, and that's obviously the direction to go on proprietary client and non-traditional NFS. The second solution is a cluster store E1000 that is basing on, originally was developed for supporting high performance computing like Cray computing, and is basing on a specific all-flash array and hardened with Lustre. So we run Lustre, the specific version of Lustre, on top of this hardware, and the Lustre is open source. I mean, it's developed originally by Intel, but is an open source parallel file system. Again, parallel file system is the key to reach the performance, the throughput performance that are needed to manage a large training environment. This section, so as we see the characteristics and some example of the high performance solution, I would like to give some highlights also on the let's say the bottom part, so the capacity oriented data platform. And when I mean capacity oriented, I'm talking low cost, large capacity platform. This is not only data lakes, but is can be a combination of data lakes, so HDFS, just meaning, or and object data store in premises or in cloud. So first point and first question, why the data store, the large capacity store for matters for AI? It matters because, as we mentioned, the data store, the data we are managing and the data we are using are amazing volume. So we are talking about hundreds of petabytes. So the solution that the data we have to store is in the order of magnitude. So, and this means that the cost by terabyte, we're not talking anymore about cost by terabyte, but we're starting to talk about cost by petabyte. And the cost by petabyte has to be accessible for managing the volume that are required for this kind of solution. I mean, the automobile is the usual example for, but I mean, it's probably on the extreme sides in volume. But I mean, if you are managing analysis for an oil company or other, don't think that the data are much smaller. Anytime you're starting to have to working with manufacturing for quality analysis and maintenance, we are talking about a huge volume in terms of volume. So we are talking about millions and millions of image to training and to manage. So, you know, image recognition need to be effective and to have a good score. You need millions of image to training your model. The other aspect, so capacity, huge capacity at low cost is important. In the case of Scality Ring is a solution that we, as HP, we embed in our hardware, is that this solution is cost effective also with the cloud environment. I think this is a very important aspect because a lot of people put data in the cloud, but they run the model in premises. This has a tremendous cost because anytime you move out the data from the cloud, you pay a toll. So it's very important, and the company are discovering that through their bill, that you have to have a good hybrid approach on the data management. So because otherwise you have to run all in the cloud, can be a solution, but that's not hyper performance because cloud cannot provide the same level of performance that you can have in premises. So you have to find again a balance, and having an in-premise solution that is compatible or it's even more effective than a cloud price. That's definitely an important element. Another important element is that there is no anymore backup. I mean, the backup is for application. Data are not anymore backuped. This is a very another strange thing that's happening in the last time. But I mean, when we are talking about a petabyte of data, the backup is a nightmare. But what is even worse is the restore. So in theory, you can backup Hadoop, but no one, I don't think no one is really was able to restore data. So as you cannot backup this amount of data, resilience is an high requirement. So it means that this data will be you have to do I don't know, 3 copies, 4 copies, but the resilience have to be at the level of a single site, multiple sites, single server, single disk. So resilience is a key aspect. You cannot lose this data, obviously. So the system you select have to have an amazing resilience. So for example, in the case of Scality Ring, that is an object store, has 14.9 of resiliency. So after the comma 99, you have another 14.9 of resilience. So you really can switch off any component of the platform, you still have your data. So in this case, I would like to show you the main aspect of the storage, the object store. I didn't mention in this presentation a Hadoop-like solution because anyone is well aware about that. Object store is a new trend in the data lake approach. People starting to talk about the object data lake. And the reason why that is because they present much more flexibility in terms of data management than traditional Hadoop-based solution. And you can see all the key aspects of this solution on this slide. So an additional element is that this solution scalability can be combined on a single machine on the Weka. So in a single environment, you can have both high performance and high capacity system on a single cluster. So you have the benefit of the two solutions on the same hardware. That's a tremendous advantage because you have really a powerful platform. So just some takeaway. More important aspect to me is that the AI and analytic platform are extremely demanding in terms of storage. And let's say in terms of data store platform. So combination between storage, physical hardware, and the software to optimize the file system approach. And the reason that because there are too many or use cases with different data pattern access, and you need to be able to support all of them. How this is translated is translated that the enterprise, your company, need to upgrade their existing infrastructure, and the upgrade have to go in a direction that they need a scale out, flexible, modular architecture that is able to span through edge, core, and cloud. So edge, core, and cloud is not anymore an option, is a must. So your architecture should be able to manage transparently data between these three entities. And obviously the scope of this architecture is balance the high performance you need for certain aspect of the AI with the low cost that you need to manage a huge quantity of data. As you see in my example, HPE is creating such architecture. So through direct development or partner agreement, we have able to run in creating a modular application from high performance or hyper performance data store on Apollo server family, and at the same time having high and low cost and high capacity solution on our platform. So, and these blocks can be easily combined to fit any need, because you see the needs of, in terms of AI analytics can be extremely different company by company, let's say time to time in the same company. And that means that the architecture have to be flexible enough and adaptable to change, to be adapted to this needs. Last slide is something of our technical library that if you are interested, we have a lot of technical reference architecture that's explaining how to implement machine learning on different environment or supporting how to use this solution, etc. That's all. That's my reference. And if there is any question, that's okay.
And you may like to go to the Q&A part, just in case any question was there. I'm also going there, just in case any. I didn't see anything new, but just want to be sure. You never know, right?
Yeah, that's okay.
No, I don't see anything new of